Right now, while you are watching this, there is a thing sitting at the edge of the observable universe that almost nobody on Earth ever thinks about. It is enormous. It is old, and it is made mostly of something you drank this morning. It is not a star. It is not a planet. It is not a galaxy in the way you picture a galaxy. It formed before the sun. It formed before the Earth. It formed before there was a single rocky world anywhere near where you are sitting. When this thing came into being, the universe itself was still a child. Here is the number that should stop you. The amount of this substance in one single place, wrapped around one single object, is at least 140 trillion times all the water in every ocean on Earth. Every sea, every lake, every drop. Multiply that by 140 trillion. That is the scale. And what the scientists found was not that this substance exists. They already expected that. What they found was how much of it there was, and how far back in time it was already sitting there, fully formed, quietly waiting. Because the light carrying this information took 12 billion years to reach us. 12 billion years. When that light left, the universe was only about 1.6 billion years old, less than a fifth of its current age. This is the story of the oldest water ever detected in the universe. And here is the part the headlines are not telling you. It is not just what the astronomers found out there. It is what that discovery quietly says about the water, right here, on your planet, in your body. It is what is happening to that light and that object at this very moment, which is stranger than it sounds. And it is what this single measurement predicts we should find in 1,000 places we have not even looked yet. Stay with me, because by the time this is over, you will never look at a glass of water the same way again. To understand why this discovery matters, you have to go back to a survey that had nothing to do with water at all. In the late 1990s, a group of astronomers was doing something slow and unglamorous. They were combing through photographic plates, hunting for cool, faint carbon stars, drifting in the halo of our own galaxy. It was patient, careful work. The kind of work where you scan and check and scan again, and most nights you find nothing worth writing down. Then, in 1998, the survey turned up something that did not belong. It was not a nearby star. It was a point of light so bright and so far away that for a while it was considered the most luminous object known in the entire universe. That object got a catalog name, not a poetic one, just coordinates. APM 08279 plus 5255. Say that name once, because it is the main character of everything that follows. APM 08279 is a quasar. And you need to understand what a quasar actually is, because the word gets thrown around like it means bright thing. It does not. A quasar is a black hole in the middle of a galaxy, feeding. Gas and dust spiral inward toward it. As that material falls, it is crushed and heated and torn apart. And just before it disappears past the edge, it releases a staggering amount of energy. So much energy that this tiny central region can outshine every star in the surrounding galaxy combined. The black hole at the heart of APM 08279 is not ordinary either. It weighs roughly 20 billion times the mass of our sun, and the quasar it powers pours out as much energy as 1,000 trillion suns. Picture that, not 1,000 suns, not 1,000,000,000,000 suns, 1,000 trillion of them, blazing out of a single point 12 billion light-years away. For years, that is what APM 08279 was known for. The brightest beacon in the dark, a record holder for luminosity, sitting quietly in the catalogs. Nobody was looking at it for water. Then two separate teams of astronomers, working independently, decided to look closer at the light coming off it. And that is where this ordinary bright dot in a survey became the site of the oldest water ever found. The turning point was not a launch. It was not an explosion. It was a decision to point the right instrument at the right light and actually read what was written inside it. So how do you find water, 12 billion light-years away? You cannot fly there. You cannot scoop up a sample. You will never touch it. All you will ever get is the light. But light is enough, because light carries fingerprints. Here is the chain, step by step. Every molecule vibrates and spins in its own specific way. Water spins differently than carbon monoxide, which spins differently than hydrogen. When light passes through a cloud of gas, each type of molecule absorbs and re-emits that light at very precise, very specific colors. Not colors your eye can see, colors far out in the infrared and the radio, beyond human vision, but precise all the same. Those specific colors do not lie. They are a signature, a barcode. So when astronomers spread the light from APM 08279 out into a spectrum, the way a prism spreads sunlight into a rainbow, they were not looking at a rainbow. They were looking for gaps and spikes, missing slivers of color, extra bumps of glow, each one a molecule announcing itself. And in that spread of light, they found water. Not one faint hint of it, 6 separate spectral signatures of water, each one a different way the molecule can vibrate, all of them pointing to the same answer. That is the whole trick. You read the water without ever seeing the water. You identify an ocean the size of a galaxy by the shadow it leaves in a beam of light that has been traveling for 12 billion years. There is one more piece. Because the universe is expanding, that light got stretched on its long journey to us. Stretched so far that signatures which started in one part of the spectrum arrived in another. This stretch has a name. Astronomers call it redshift, and for this quasar, the redshift is about 3.9. That single number is doing a lot of quiet work. It tells you how far the light traveled, how far back in time you are looking, and by exactly how much every fingerprint got shifted before it arrived. Astronomers have to account for that stretch, undo it in the math, and only then do the fingerprints line up. And the water was not the only fingerprint in there. Alongside it, the astronomers read a whole ladder of carbon monoxide signatures, the molecule that does most of the work of shedding heat from this gas. Water and carbon monoxide, side by side, reading out from the same distant cloud. 6 water transitions, each corresponding to a different energy state of the molecule, some of them reaching energy levels equivalent to hundreds of degrees. Most of those water signatures had never been detected this far out in the universe before. They were first detections, new entries in the record. When it all lined up, the answer was unmistakable: water, an enormous amount of it, present when the universe was 1.6 billion years old. Think about what that method really is. You are not photographing an object. You are decoding a barcode printed in light, stretched by the expansion of the cosmos, dimmed by 12 billion years of distance. And you are recovering from it the chemistry of a place you can never reach. It is closer to forensic science than to sightseeing. You reconstruct the scene from the faintest possible trace. Now let me tell you why this measurement was so close to impossible. Because the difficulty is the whole point. Start with the distance. 12 billion light years. A single light year is about 6 trillion miles. So the light you are measuring has crossed something on the order of 30 billion trillion miles to reach a telescope on Earth. Written out, the distance to this water is a 3 followed by 22 zeros, in miles. By the time that light arrives, it is faint almost beyond belief. You are not catching a flood of photons, you are catching a whisper, and you are trying to pull 6 specific molecular signatures out of that whisper. To do it, one of the teams, led by Matt Bradford at NASA's Jet Propulsion Laboratory, used an instrument called Z-Spec. They mounted it on a 33-foot telescope near the summit of Mauna Kea in Hawaii, at the Caltech Submillimeter Observatory, 33 feet across, sitting on top of a volcano, above most of the water vapor in our own atmosphere, because our own air gets in the way of reading water in space. And it was not quick. Bradford's team began observing in 2008. Reading this one object took a total integration time of about 25 hours, gathered across 13 separate nights, and 4 observing campaigns spread over more than a year. 25 hours of staring at a single point of light, in the cold and the thin air, coaxing a signal out of the dark. And even that number understates the difficulty, because you cannot just point and record. The Earth's own atmosphere is full of water. That is a problem when the thing you are trying to measure is water 12 billion light-years away. Your own air keeps trying to drown out the signal. So the astronomers had to observe from high on a volcano, above as much of that atmospheric water as possible, and they had to calibrate their instrument against known objects in our own solar system, using planets like Mars and Uranus as reference points to be sure the numbers meant what they thought they meant. Every reading had to be checked against something trustworthy and close before it could be trusted about something untouchable and far. Then they did something careful. They confirmed it. Follow-up observations were made with Karma, an array of radio dishes in the Inyo Mountains of California, to check that the water was really there. Meanwhile, a second team, led by Dariush Leese at Caltech, had come at it from a completely different direction, Using the Plateau de Bure interferometer in the French Alps, they had detected water in this same quasar back in 2010, almost by accident, catching a single spectral signature. 2 teams, 2 continents worth of instruments. One team catching a single fingerprint, the other catching 6, and with those 6, measuring the mass, and both arriving at the same distant object, 12 billion years back in time. The results were published in 2011 in the Astrophysical Journal Letters. Not a press release, a peer-reviewed paper, and one of the co-authors, Alberto Bellato, of the University of Maryland, put the meaning of it plainly. Because the light left this quasar more than 12 billion years ago, we are seeing water that was present only about 1.6 billion years after the beginning of the universe. That single sentence is the whole discovery in miniature. Not a claim that water is exotic, a claim about timing, about how early the universe had already assembled this ingredient and in what quantity. It is worth pausing on how ordinary the beginning of this was. Nobody set out to break a record for the oldest water. A survey for faint carbon stars stumbled onto the brightest object anyone had ever catalogued. Years later, one team pointed a spectrograph at it and caught a whisper of water almost by accident. Another team, an ocean and a continent away, went in deliberately and pulled out 6 signatures. There was no dramatic eureka moment broadcast to the world. There was patient work, repeated checking, and 2 independent results that happened to agree. That agreement is what makes this solid. When 2 groups using different instruments on different mountains land on the same answer, you stop calling it a fluke. Here is the first finding, and it is the one that gives the video its title. This is the oldest water ever detected. Remember the number. The light took 12 billion years to reach us. That means we are not seeing this water as it is now. We are seeing it as it was when the universe was only about 1.6 billion years old. Sit with what that means. When this water was already there, in that enormous quantity, the Earth did not exist. The Sun did not exist. Our entire solar system would not form for another 8 billion years or so. The universe was less than a fifth of its current age, still building its first generations of galaxies. And water was already there, in staggering amounts. Now here is the honest part, the part an exaggerated headline skips. Scientists were not shocked that water existed back then. They expected it. Water is made of hydrogen and oxygen. Hydrogen has been around since almost the very beginning. Oxygen gets forged inside stars and scattered when those stars die. So once a few generations of stars had lived and died, the ingredients for water were on the table. What the discovery actually did was push the confirmed detection of water about 1 billion years closer to the Big Bang than anyone had managed before. It did not rewrite physics, it set a record, and it turned an expectation into a measurement. That distinction matters, and this channel is not going to blur it for you. There is a real difference between believing something should be true and proving it is. Before this, the idea that water existed in the very young universe was a reasonable expectation, resting on how stars build and scatter oxygen. After this, it was a line in a spectrum, 12 billion years old, measured twice by 2 teams. The universe stopped being a place where we assumed early water and became a place where we had seen it. That is what good science does. It moves a claim from the column marked probably into the column marked measured, and it does so quietly, one careful observation at a time. The second finding is the quantity, and this is where the scale becomes almost unreal. At least 140 trillion times all the water in Earth's oceans. That is the water vapor wrapped around this one quasar. The gas cloud holding it is estimated to be around 100,000 times more massive than our Sun, just in water. Let me translate that into something you can hold. If every ocean on Earth were a single drop, this reservoir would be 140 trillion drops. It is not water on a planet. It is not water in a comet. It is a fog of water vapor spread across a region hundreds of light years wide, surrounding a feeding black hole. For comparison, look at our own galaxy. The Milky Way has water in it too, but the total amount of water vapor floating in our galaxy is roughly 4,000 times less than what sits around this one quasar, and most of the Milky Way's water is not even vapor, it is frozen, locked up as ice. So this is not just more water, it is water in a form, and at a density, that our own galaxy does not come close to matching. 140 trillion oceans, 12 billion years ago, when the universe was 1.6 billion years old. The refrain is the record, and here is an honest caution about that headline number. 140 trillion is a floor, not a ceiling. The astronomers describe it as at least that much. It is the minimum consistent with what they measured. The true figure could be higher. This is the opposite of hype. When scientists are unsure, they tend to state the smallest number they can defend, not the largest they can imagine. So when you hear 140 trillion oceans, understand that the real reservoir is not being inflated for effect. It is being stated conservatively, and it is still almost impossible to picture. That is the difference between a headline and a measurement. A headline reaches for the biggest word. A measurement reaches for the number it can stand behind. The third finding is the strangest, and it is about temperature. You would assume that water this far out in deep space, this early in cosmic history, would be brutally cold. And, in human terms, it is. The gas sits at roughly 63 degrees below 0 Fahrenheit. That is colder than any winter you will ever stand in. But here is the twist. For deep space, that is warm. The astronomers describe this gas as unusually warm and unusually dense, by astronomical standards. It is about 5 times hotter and somewhere between 10 and 100 times denser than the typical gas drifting between stars in a galaxy like ours. Why? Because of the monster at the center. That 20 billion solar mass black hole is flooding the surrounding gas with X-rays and infrared radiation. It is bathing the whole reservoir in energy. The water is not just sitting there. It is being heated and lit up from within by one of the most violent objects in the universe. And yet, at the same time, this dense gas is still almost nothing by earthly standards. It is estimated to be around 300 trillion times less dense than the air you are breathing right now. So it is warm for space and dense for space, while being emptier than the best vacuum you could ever build on Earth. Both things are true at once. That is the kind of contradiction deep space forces you to hold. The fourth finding is what this water tells us about the object itself. And this is where honest uncertainty comes in. The water is not just a curiosity, it is a diagnostic. Because water responds so sensitively to X-rays and infrared light, its exact signatures let astronomers work backward and figure out the conditions around the black hole. The presence of this warm, dense water vapor is direct evidence that the quasar is drenching its surroundings in radiation, and that a huge amount of gas is packed into a region hundreds of light-years across. The researchers modeled it as gas spread over a region roughly 550 parsecs in size, feeding and being fed on at the same time. Water became the thermometer and the density gauge for a place no instrument will ever visit. And that is a genuinely elegant idea worth slowing down on. You cannot put a probe into this cloud. You cannot lower a thermometer into it. You will never take a sample. So instead, the water itself becomes your instrument. The exact pattern of its signatures, which lines are bright and which are faint, tells you how hot the gas is and how densely it is packed. Because water only glows in those particular ways, under those particular conditions. The molecule you are trying to measure ends up measuring its own surroundings for you. 12 billion light-years away, a fog of water vapor is quietly reporting the temperature and pressure around a black hole, and all you had to do was learn to read it. But researchers still cannot fully map everything about this reservoir. The measurement depends on models of how the light is bent and magnified on its way to us. Because this quasar is gravitationally lensed, its light is warped by the gravity of matter between us and it, which brightens it, but also complicates every number you extract. So the exact total, the exact geometry, the exact way that water is distributed, all of it carries real uncertainty. The headline says, found, the scientists would say, detected, measured, and still being understood. That gap is not a weakness in the science. It is the science being honest. There is one more thing about this quasar that makes the whole measurement even stranger, and it is the reason you can read water 12 billion light-years away at all. APM 08279 is one of the most luminous objects ever found. When it was first identified, its apparent brightness was so extreme that it was considered the most luminous object known in the universe, pouring out roughly the light of 1,000 trillion suns. That blinding output is what makes it visible across 12 billion years. A fainter object at that distance would simply be lost in the dark. This one is a lighthouse. But part of that brightness is a trick of gravity. This quasar is gravitationally lensed. Somewhere between us and it, there is mass. and that mass bends and magnifies the light on its way to Earth. The way a lens bends light to a focus. That magnification is a gift, because it makes a distant object bright enough to study. And it is a curse, because you have to model exactly how much the lens is boosting the light before you can trust any number you pull out. That is why researchers still cannot pin every figure to a single value. The mass of the water, the size of the region, the density of the gas, all of it depends on the lensing model you assume. Change your assumptions about the lens, and the numbers shift. The astronomers worked with a particular, now favored model of that magnification to reach their figures. But they are honest that these are model-dependent results, not marks on a ruler. The reservoir is real. Its exact accounting is still being argued, 12 billion years after the light left. That uncertainty is not a flaw in the story. It is the story told honestly. Now come back to the loop I opened at the start. What does any of this have to do with the water on your own planet? With you? This is the quiet payoff. If water in this quantity was already assembled around a quasar when the universe was only 1.6 billion years old, then the raw ingredient for oceans, for rivers, for rain, for life as we know it, was ready extraordinarily early. Water did not have to wait for a calm, mature universe. It was pervasive, almost from cosmic dawn. The water in your body traces back to hydrogen from the beginning of the universe, and oxygen forged inside dead stars. This discovery is one more piece of evidence that the story of that water starts far earlier and far more widely than we used to be able to prove. You are made of an ingredient the cosmos was mass-producing 12 billion years ago. So where does this go next? Here is the honest answer, and it does not come with a countdown clock. There is no locked date on the calendar for APM 08279. The light will keep arriving. Astronomers will keep pointing better instruments at it, refining the numbers, tightening the models, arguing about the lensing. But there is a strange truth buried in that. The water we are studying is a 12 billion-year-old snapshot. Whatever became of that gas, whatever that black hole did with it, over 12 billion years, has already happened, out there, long ago. We are reading a message with an impossibly long delay. The object we are analyzing right now is really the object as it was before the Earth existed. What it looks like today, we will not know for another 12 billion years. And the forward-looking part is not about this one quasar. It is about the prediction it makes. If one early quasar could hold 140 trillion oceans of water this early, then it should not be alone. There should be others. Newer instruments and the generation of telescopes now coming online are built to find exactly these kinds of molecular signatures, deeper and fainter than ever before. The reasonable expectation, the testable one, is that this record will not stand forever. Someone will find water even older, even farther, even closer to the beginning. And notice what that quietly does to the meaning of the word oldest. This is the oldest water we have detected. It is almost certainly not the oldest water that exists. Those are two very different statements, and the honest one is the second. Records like this are made to be broken. Every time our instruments get a little more sensitive, the frontier of what we can confirm moves a little closer to the beginning of everything. 140 trillion oceans, 12 billion years back, a universe only 1.6 billion years old, is not the end of the story. It is the current edge of what we can prove. That is not hype. That is just where the evidence points. So let me leave you with the numbers that carried this whole story. 140 trillion oceans, 12 billion years of travel. A universe only 1.6 billion years old, already holding water in amounts we can barely describe. None of that is exaggerated. Every one of those numbers comes from two independent teams, real instruments on real mountains, and a paper published in a peer-reviewed journal in 2011. The title says, "Scientists found the oldest water in the universe." That is true. What is also true, and more interesting, is that they did it by reading a whisper of stretched light and refusing to overstate what it meant. There is something worth sitting with in that. The same molecule filling your glass this morning was already gathered in unimaginable quantity around a black hole 12 billion years ago, when the universe was barely getting started. And it is genuinely worth wondering how much older and how much farther that water might still be hiding. If you want more space stories told this way, grounded in real published research, rather than exaggerated headlines, subscribe and turn on notifications. We break down real discoveries without the exaggeration. I will see you in the next one.